Man. Sometimes I hate Microsoft. Here we go. Most of the time. All right, so I pulled this up into a document so I can show you guys. So this is a empirical rule graph, and there's one presented in your textbook, but the one in your textbook is missing this black parts of the graph, and these are really important. So the empirical rule, also called the 68-95-97.7 rule, tells us that 68% of the data lies within 1 standard deviation of the mean, 95% of the data lies within 2 standard deviation of the mean, and 99.7% of the data lies within 3 standard deviations of the mean. So what they've done here is this first part is the 68%. So here's the mean, which is the 50th percentile. And then 68% of the data lies within 1 standard deviation of the mean. So that's from the mean, mu, minus 1 standard deviation, which is 1 sigma. And this value corresponds to a z-score of -1. And then over here, we have mu plus 1 sigma. So that's the mean plus 1 standard deviation. So this corresponds to a z-score of 1. So basically what I have here is this is a z-score of -3, -2, -1, 0, 1, 2, 3. So these represent z-scores. And since the way they got this 34% is they took the 68%, divided it by 2. So 34% is here and 34% is here. And then 95% of the data lies within 2 standard deviations of the mean. So since 68% is here, 95 minus 68 is 27%. And then we divide that by 2, and 13.5 is here, and 13.5 is here. And then 99.7 lies within 3 standard deviations of the mean. So if I take this 95% and subtract that off from the 99.7, I get 4.7. And so we split that in half, and 2.35 is here, and 2.35 is here. And then what I have left over, because all of this needs to add to 1, is 1 minus 99.7, which is 0.3. And when I divide that by 2, I get 0.15% out here and 0.15% out here. So that's how they draw this table. So this rule is an approximation to the actual values under the curve for a bell-shaped curve or a normal distribution. So this is an approximation. Later on, you guys are going to learn next week, you're going to learn how to calculate the actual real values under the curve. But for now, this is just an approximation. So based on this, I can now figure out percentiles. So the percentile, if you are in the 90th percentile, that means that you're way out here in the data. And 90% of the students have grades lower than you. And 10% of the students have grades higher than you. So it's always, the percentile is always the area to the left. So this value, a z-score of -3, corresponds to the 0.15 percentile. A z-score of -2 corresponds to the 0.15 plus 2.35 or 2.5 percentile. A z-score of -1 corresponds to 0.15 plus 2.35 plus 13.5, which is 16%. So that corresponds to the 16th percentile. And then when I take 16% plus 34%, the mean corresponds to the 50th percentile. This is a z-score of 0, which is the 50th percentile. And then mu plus 1 standard deviation is 50 plus this 34, or the 84th percentile, and so on. So that's how you calculate the percentile, by adding up the numbers to the left. So I recommend that you take, I posted this empirical distribution in the chat. I posted 2 of them. This one is better for me to show you guys where it came from. The other one might be easier for you guys to use. And this over here is just confusing, guys, so just ignore this. But anyway, so you're going to use this to do question number 1 on your homework today. And this is how you use it. And I recommend you grab one of these and pop it right into your Excel spreadsheet. And then you might even want to go ahead and calculate all the percentiles that go with it, from z-score of -3 up to a z-score of +3. So you can just calculate the z-score and then just look it up in the table. But remember, when you go to do your final exam, you're only going to use this if they tell you use the empirical rule. If they don't tell you to use the empirical rule, you're going to want to calculate it like the actual value, because these numbers, obviously, like this gives you, this value, like I said, is the 16th percentile. But if you looked it up, or in the table that you'll learn later, or calculate the actual real value, it's not going to be 84. It's going to be 84.1357 something. So it's going to be some other number, and they're going to ask you for it to like 4 decimal places. So anyway, I just wanted you to know that. But when they ask you to use the empirical rule, they'll never ask you for more than 2 decimal places, but typically they'll want the values to more decimal places. So that's kind of how you can also tell. So I hope that helps with this part. And I'm sorry, I had recorded another video showing you guys how to do this, and I couldn't find it to attach it into the chat. So now I've gone over it for you. So hopefully that'll help and you can use that. And I can't add this into the homework because once you guys start the homework, I can't, unfortunately, make any changes to the homework. But let me stop recording. But I will